what are the limitations of using CAM verification? So get into CAM verification. Most CAM systems offer some level of verification based on CL data. That's centerline data, cutter location data. It has quite a few names. It's debatable on what its true meaning is. We won't go into detail. We'll just call it CL data. CL data is then post-processed into machine-specific G-code. So in a sense, which means the CAM system simulated something different than what the real machine will run. And that's one of its main hurdles. They're getting better. We'll get into some other options that they have and other options that other softwares and other verification processes have. In a sense, any simulation which runs on CL data cannot be fully trusted. So if it's not run the exact same thing that the true machine is running, then obviously there's going to be a difference. Some guessing, projecting what it's supposed to be doing versus what it's actually doing. The post-processor itself can introduce errors, damage the part, or the machine. Most CAM verification use component software for machine simulation, which is typically an outsourced, generic, integrated third-party plug-in into the software, and then, they kind of integrate it together. And it's mainly just for material removal. It's not for actually emulating the true machine. So integrated post-processor verification. There's some verifications out there that, are saying, hey, yeah, we're simulating the actual G code, when in a sense they're kind of posting it and simulating at the same time, and they're kind of projecting what their post is supposed to be doing. So as we previously discussed, that post-processors can introduce errors. So how can you trust a post-processor driven simulation? Who checks the post-processor? Typically, next deals is the alternatives to verification. So what do most programmers do? Check very, very carefully. They basically, I've known programmers to print it out and it'd be a couple hundred pages of program code, and they just sit there and go line by line, and of course that's redundant and they can miss a lot of things. Another alternative, what do most machinists do? Low feed rate, single block, and risk of collision. That's where you're proving it out on the machine, and now you're holding up the machine, not letting it run its full potential. Typical CAD/CAM process chain, which is where that comes in, and why it takes a week to set up something that runs in an hour. You got your production planning, your manufacturing. So typically in planning, you got CAD design, which goes over to CAM. Let's go ahead and program it, get it programmed, take the CL data, post-process it, and send it to the machine. Is the G code good? We're not sure yet. So we sit there and we prove it out with the machine. Program's bad, iteration, send it back to CAM. Now your machine's sitting there because you may still have the part on it. So now you got an idle machine while it's getting fixed or updated or just, maybe improved. Maybe it just was inefficient. So now we've done our iterations. We've got a good program. Now we can go off to series machining. So once you introduce some third-party verification, you still got the CAD design, you still got the CAM, except for the CL data post-process G-code file. Is it good or not? We'll send it into verification, check it. Oh, it's bad. Send it back. Iteration, couple iterations, 3 or 4 or 5. Okay, it's finally good. Now we can go and go straight to. So we just cut out the whole prove out process. Right there is quite a bit of time already saved. Now, and then you can get into the optimization if you get a verification that has optimization features, and then cut down on even more of the time and add a little bit more time savings.